start. And then I will focus on the Swisstronic plugin, because the Swisstronic plugin is also $600. Okay, another question. Actually, let me see again. Okay, so I just created the React app, which is here. So I will just access to that React app. Also, if you get lost or something, don't be shy and let me know. I can stop or I can just explain again. The idea is that you are able to follow. So what I did was just to create a new React app, and then we have this app here. I will just run this in the browser, npm run start. And then we have the React app here. Okay. Oh, also, just to let you know, we are going to do this workshop until 2 or 2:30. Then we have lunch, and then we can spend a couple of hours like coding or doing whatever you want, and then I will be here to help you if you need something. So what I'm going to do now is just to remove some things here that we don't need. Okay, I will just leave it like that. Perfect. And then I will create maybe a button. Yeah. Maybe a button to interact with a Swisstronic token. In the Swisstronic network, when you come here to the Block Explorer, you will see that they have ERC20 tokens, ERC721 tokens. So I will interact with the ERC20 token. So I just click here, and then I will see a lot of tokens here. Normally, a ERC20 token will have some functions. Who don't know what is a ERC20 token? You know, how deep should I explain that? Okay, so a ERC20 token is a smart contract that have some functions that you are able to, okay, in the blockchain you can only do two things. Send transactions, like write data, that's a send transaction when you want to write data, or fetch data. So just those two things. I call it writing functions or reading functions. So for writing functions, you will always need funds to be able to write something. A writing function, for example, is minting. When you mint tokens, let's say that I created a token, my token Santiago, right? And I have 0 tokens, like no one has tokens. But then I mint 10 tokens, so now I have 10 tokens, right? So what I am doing in the blockchain is, let me just put this here, that would be easier. When I mint tokens in a smart contract, I'm basically having a mapping. Do you know what is a mapping? Okay, a mapping is, how is that called? Key value pair. And a key value pair in the token is having an address with a balance. And then what happens is that instead of an address, let's say that is a name. So Santiago has 0 tokens. But then if I mint tokens, we are updating this mapping saying Santiago has 1 token. Or then if I mint 1 more token, now I'm updating the mapping again. A mapping itself is just a data structure of a key. In this case, the key can be the address or my name. And then the value is the balance. It's just a number, right? 2 tokens. So a ERC20 token in blockchain this is basically the most important part of a token, the mapping of an address and a balance. Because then the address will always point to a balance of how many tokens you have, right? So in this case, I have 0 tokens, but then if I mint tokens, then I have 1 token or 2 tokens. But in real life, this will look something like this. Let me just get this address. In real life, this will be something like that. This address has 0. Let me just copy this. This is another address, and this is another address. 1, 2. Okay, so I have 3 different addresses here, and the addresses are connected or are mapped to 0, right? Because this address has 0 tokens, this address has 0 tokens, and this address, and etc. All the addresses by default will be connected to a 0. But then when one of these addresses mint, then we need to update the mapping. That's why it's called like writing in the blockchain, because now we are writing a new data that says that this address has now 10 tokens, for example, or 100 tokens or whatever. Are you able to get this part of the mapping now? Like the mapping, a data structure that connects a key and a value. In this case, it's an address with a balance, that is a number. So basically, this is ERC20 token, a mapping of this, but then you have different functions to do that. You have, for example, a function, a reading function can be balance of. Let me actually go through this. I created a really easy token. I think it's this one. Okay, maybe let's go through this, so you are able to understand a little bit about tokens. So this is how in Solidity we can write a mapping. In this case, mapping the keyword, then the address to U256, and then I call it balances. And then when I mint, what I am doing when I'm minting tokens is just updating the balance of a specific address. In this case, it's called message.sender, to say that now the balance of this address is plus equal 10. So what I'm doing when I'm minting is just updating this data structure to 10. Do you guys have any question with this line 19? I mean, we're not supposed to touch Solidity today, but I just want you to be able to understand this, the concept of ERC20 tokens. So remember that we have this mapping in the smart contract. Maybe this can be a little bit confusing, all this Solidity code. And then we are just updating this mapping and minting 10 tokens. And then when we want to burn tokens, kind of disappear tokens, we are doing the same, but then minus equal 10. And now this address, message.sender is an address, but just to make it less confusing, we can hard code the address here. So when we are minting 10 tokens, we are minting for this address 10 tokens, or when we are burning for this address 10 tokens. And that's how a ERC20 token works. So the ERC20 token is just a standard of all the tokens that you see in the blockchain, in Ethereum network, and they will always have these specific functions that are, for example, let me come here, ERC20, I think here. Let's see. Yeah, so the ERC20 always will have a total supply, a function balance of that will retrieve the balance of a specific address, a function transfer that will allow you to transfer tokens from one account to another account, and here the amount, etc. So the ERC20 is just a standard that allows you to interact with all the tokens in the blockchain. And then because we already know that, if I call the total supply in any ERC20 token, you will see that we will always get a total supply. So I want to interact with that contract on Swisstronic for you to be able to see that all of them have the same standard. So, okay, so now to start, let me go back to my React app. So I'm going to create some buttons to interact with this ERC20 token. One can be get name, get total supply, because I know that all the ERC20 tokens will have these functions, one that returns the name and one that returns the total supply, right? We have that in the ERC20 standard. And here are all the functions. So if I call the function name, symbol, total supply, that will work. Let me just create this, get symbol. Okay, so far, I just created a React app with 3 buttons: get name, get symbol, get total supply. I haven't done anything else, right? Any questions so far? I'm being too fast? No? Don't be shy. I'm okay? Okay, perfect. So I just created 3 buttons. Now the most important thing is that we need to install two things. Maybe let me update this README with the steps. Install web3.js. Install Swisstronic plugin, initialize web3, register plugin, initialize contract, and then call contract. Okay, so we are going to do this. The first one is to install web3.js. So to install web3.js, npm I web3. So npm I web3. The second one, install the Swisstronic plugin. So for the Swisstronic plugin, you will need to do the same later when you are making your dApp. You will kind of follow the same steps. So for the Swisstronic plugin is this npm package. npm install Swisstronic web3 plugin Swisstronic. So I'm installing it here. And we can see that in the package.json we have web3 here. And then the Swisstronic will be there soon. Okay, and Swisstronic here. Who has any questions so far? I have just done 2 things. Okay, and also I created the buttons. Create buttons. So I just created the buttons, install web3.js, install the Swisstronic plugin. We can see that we installed the web3.js here and also the Swisstronic here. Any questions so far with this step 1 and 2? Okay, great. Now we need to initialize the web3 object. So this is really important because if you know JavaScript, this line of code, these 2 lines of code will be really important because that will allow you to have any Web2 app into a kind of Web3 to interact with MetaMask. So we need to, okay, and then we also need to import. So let me just put, yeah? Sorry? Documentation? Yeah, but you know, you don't even need to know. This is the documentation for the Swisstronic plugin, right? But then for the Swisstronic blockchain itself, they have the docs here. Oh, I don't know why it's not allowing me. Oh, yeah. And then these are the docs of Swisstronic. But to be honest, you don't even need to go through their docs. You only need to go through the plugin. I mean, if you want, you can just go here and then you will learn more things about Swisstronic. But the purpose of the plugin is that the plugin is abstracting this encryption that they have and all these things. But yeah, then here you have the docs as well. Let me just put some resources. Okay. Swisstronic docs. Swisstronic plugin. Okay, so once we install Web3 and Swisstronic, we need to import those 2 modules, right? So to import that, I will come here and then import Web3 from Web3. That's how we import the Web3 library, import Web3. And then import Swisstronic plugin. I will also copy this in the README. Install and import. And then okay, I'm trying to put everything here so it's easier to follow later. So install the web3.js. This is how we install the web3.js library, and this is how we import it. Then install the Swisstronic plugin. This is how we install the plugin, and then this is how we import the plugin. Any questions so far? Perfect. Okay. Then after that, we need to initialize the web3 object. So the object that we need to initialize is this web3 with the W uppercase. So let me just put it here, initialize web3 object. To initialize that object, we need to type new web3, uppercase, because we are using this web3 from here. And then we open the parentheses. And then here is the keyword that you will learn today that is called window.ethereum. When we have this window.ethereum, we are connecting to an object in the browser that is called Ethereum, and then this will trigger MetaMask later. I'm going to show you that in 2 lines of code. And then we need to store this in a variable that I will call web3 lowercase. So yeah, this is important to note. We are initializing new web3, but this web3 is W uppercase. And then I'm storing this instance in this web3 lowercase. Is this clear? Line 12? Perfect. Okay, now I initialize the web3 object, right? And then after I initialize the web3 object, I need to do something that is called register plugin. This register plugin is just used to to kind of initialize the Swisstronic plugin. So in this case, Swisstronic plugin. To register the plugin, we need to use this Web3 instance here. This Web3 instance is the one that we are going to use for everything. So it's really important, this Web3. So if you put a different name here, you will need to use that name. So I will need to type Web3 register plugin. And then in the parentheses, I open parentheses, and then I need to send the new instance of the Swisstronic plugin. New Swisstronic plugin. And then the parentheses. If you go to the docs of this npm package, you will see what I'm doing here as well. Import Web3, import Swisstronic, initializing the Web3 object, and then registering the plugin too. Any questions so far? I have done these 4 lines of code, right? Perfect. But then something important is the Swisstronic RPC endpoint. So this endpoint is basically telling the Web3 object where do we need to, like which blockchain we are interacting with. So that's why I just copy paste this, JSON RPC testnet Swisstronic, to be able to tell like the Web3 object, like, hey, we are interacting with Swisstronic. So this is really important. When we register the plugin and I open the parentheses, you see that here the Swisstronic plugin is asking for a RPC endpoint. So that's why here I'm putting the Swisstronic RPC endpoint that we are going to interact with. So let me just copy this here too. Register plugin. Okay, so far I have done these 4 steps. Maybe before we initialize the contract, I'm just going to show you how easy it is to connect MetaMask to the dApp. Maybe by calling, I'm going to create a function that I will call it connect. And then if I use this Web3 instance, web3.eth.request accounts, only by typing this line of code, MetaMask will pop up in the browser to ask the user to connect an account. So I'm going to show you that. I'm going to store the accounts in these variable accounts, and then I'm just going to print that in the console. We will need this later, but I just want to show you this really quick. And then let's say that this get name will call the connect function. Any questions so far with this line 17 or something else? I'm using the Web3 instance. Remember that this is the most important keyword of the app, because this is how we are going to interact with the blockchain. If you call this something else, let's say provider, so then we will need to type provider.eth.request accounts. But yeah, I always call it Web3. And if you want to know more about Web3.js, you can come also to the docs. And then you will see that the function here in the API, or here in packages, I'm using the web3.eth package. And then I'm using the request accounts. Where is the here? Request accounts. And then here is the explanation. This method will request the user to connect the accounts and all these things. But yeah, then what I'm doing here is just typing web3.eth.request accounts, storing the accounts that the user connects in this array of accounts, and then just printing that in the console. So if I come to my React app, let me just disconnect first. And then if I click in the get name button, you can see that MetaMask is popping up here, and it's asking me connect with MetaMask. Select the accounts to use on this site. And then if I select these 3 accounts, let me just open my console. Okay. And then if I click in next, then in confirm, didn't. Okay, let me just try again. Oh yeah, it shows here the array. Oh yeah, it returns this array with the 3 accounts that I connected. But if I connect only one, then it will return an array with 1 account. Do you have any questions so far with this to connect the accounts? If it's a new account, it can also connect. For example, I can create a new account. So to create a new account, I can come here and then say add account, and then add a new Ethereum account. So I will say new account. And now you can see that this account has 0. This is just a new random account. MetaMask just created a new random account right now. And then let me just disconnect. So when you click in get name, in this case, when you call the web3.eth.request accounts, you will not see all these accounts, right? Just because I have a lot of accounts here. You will only see this new account. So you will only have one option to connect with that account. Then you will click in next, confirm, and then you will be connected now to that new account. Perfect. Any questions so far with connecting accounts? Okay, we will need that function for later, so let me just put here connect accounts. And then connect accounts. Okay, perfect. And now let's interact with the contract. So to interact with a contract, remember that we have two functions that we can interact with the contracts. If you are new to Web3, I will advise you to just interact with reading functions, so you don't need to mess up with the connecting accounts, because reading functions. So let me show you something else here. Maybe here. Reading functions and writing functions. So reading functions only retrieve data of the blockchain. So for example, we have Santiago token, right? And I want to know your balance. So I can call a function that is called balance of, what's your name? Judith. Judith. So I can call balance of Judith, and then what that function will do, just return your balance. In this case, will be 0. So I'm just calling a reading function because that's just reading information, right?
Just functions inbuilt or customized them?
That's in the smart contract when you deploy a contract in the blockchain. But then, yeah, that's like, okay, if I have a contract and then that function is called balance of, and I deploy the contract to the blockchain, that will be the contract forever. Like you cannot change a smart contract once you deploy the contract. So that function will be always called balance of. And in the ERC20 token standards, the function is always called balance of. That's why I can call the function balance of any ERC20 token, and I will know that that function works because that's called like that. That's the beauty of the standards, that you will always call the same functions. Or I can call the function name to, that's what we are going to do, to call the function name to a lot of different contracts, and we will always get a different name because we are interacting with different contracts. So the function name is also a reading function because it's just returning the name, right? Or it's just returning the balance, or it's just returning the total supply. So this only retrieve data of the blockchain. But then the writing functions will either remove, edit, change, or whatever data in the blockchain. So it's, if, for example, Judith, you have 10 tokens now. It's like this, Judith?
Yeah.
Perfect. Judith has...
J.
Is like that? Perfect. Judith has 10 tokens. But then you transfer, let's say, Santiago 10. So if you call this function transfer, and you say 2, in this case Santiago is 2, 10 tokens, then after the result will be that Judith has 0 tokens, right? So what happened is that we are updating the mapping that I mentioned before, and now you don't have 10, now you have 0, because we changed something, and now Santiago don't have 0, now Santiago has 10. So this is a writing function. Transfer is a writing function because we are changing the balance of Judith and the balance of Santiago. So these are the difference of writing functions and reading functions. And for the reading functions, you don't need a wallet, because to only read data, you don't need to have a wallet, you don't need to have an account. I'm going to show you that right now. But for writing functions, you need a wallet with funds, right? Because if you need to transfer 10 tokens, you need to have the tokens in an account, right? And you also need to pay for the gas fees of that transaction. So that's why you will always need a wallet with funds to interact with writing functions. But to interact with reading functions, you don't need anything. That's what we are going to do now. Any questions with this so far? Perfect. That's only the two types of functions in the smart contracts, reading and writing functions. And then let's interact with the reading functions. So the first thing that we need to do is to initialize a contract. Maybe this is kind of useful. Yeah. Maybe let's put that here. Yeah, let's just leave it like that. So to initialize a contract, we need to type new web3.eth. That's why this is always the keyword that we need to use, web3.eth.contract. And then this will receive two parameters. The first one is an ABI, and the second one is an address of the contract, right? The ABI is just a JSON object with the different functions that we have in the contract. I'm going to show you that right now, and then we need to store this in a variable that I will call contract instance. So let me just do that in the code. Okay, same function. Let's say, oh, actually I can do that here. Initialize contract. So const contract instance equal to new web3.eth.contract. And then when I open the parentheses, you can see that this receives a contract ABI and then the address. So ABI, let's put it ABI and address. So how we can get the ABI? So in this case, because we are going to interact with the ERC20 token, remember that the ERC20 tokens are a standard, so they will have always the same ABI. So if I put ERC20 ABI, you will see this ABI here. You don't need to know anything about the ABI, you just need to copy paste this to be able to interact with any contract. If you are interacting with a different contract, that contract will have its own ABI. So this is just the ABI of the ERC20. I just copy all of this. Then I will create, yeah? Sorry? Oh, application binary interface. But then the ABI, let me show you what it is here right now. So ABI, maybe const ABI. So ABI is just this whole object here with all the different functions that the ERC20 token has. So if I check, for example, balance off, we can see that the function exists here. Or if I check the function name, oh, we have a lot of names here. Yeah, the function name also exists. Or if I check the function decimals, the function exists. So this is just an object that we need to pass to web3.js to be able to interact with this contract. You don't even need to know anything about the ABI, but you can get the ABI of any contract in the block explorer. For example, if I check USDC, USDC is a token, Etherscan. And then here you will be able to find the ABI. When you come to contract, you will see the Solidity code here. But then if you scroll all the way down, you will see the ABI here. And then the ABI is a ERC20 ABI, maybe with more things, because maybe this contract is a little bit more complex than a normal ERC20. But they will have the normal ERC20 plus some other things, right? So yeah, you can just copy the ABI here, and then just copy it here. And that's it. We just need to copy paste the ABI to initialize the contract instance here. So I just created this abi.mjs, and then I will export that, export default ABI. So literally I just copy paste the ABI here, then I will import the ABI, import ABI. Okay, and we can see that we imported this object from here. Then I will update my contract with the ABI and then the contract address. So the contract address is the address of the smart contract that I want to interact with. So if I come to Swisstronic, we can see that in ERC20 tokens, we have a lot of tokens here. So I will just choose the first one. And then I will just hardcode the address here. Maybe it becomes address. Okay, so we will always need to initialize a contract, an ABI, and an address. Any questions so far with this? Yeah.
Would I use a plugin when I'm using Motoko?
Oh, Motoko is for ICP.
So what's the difference?
What's the Motoko of Ethereum? Okay, okay, perfect. That's a different blockchain. This is Ethereum. But that's a good point. In Kenya, I got that question too. So Motoko is the solidity of Ethereum. So Motoko is
I'm mentioning about solidity, and Motoko is also.
is the solidity of ICP. So Motoko ICP, solidity Ethereum. The difference is that Motoko only works for ICP, I think, but then Solidity works for smart contracts on Ethereum, Avalanche, Celo, Base, all the Ethereum virtual machine compatible blockchains, you will use Solidity. Motoko is only for ICP. For smart contracts in ICP, and then Solidity for smart contracts in any Ethereum blockchain. Perfect. Any other questions? Yeah?
Thank you. You said we are going into that file again.
The ABI. So there are different ways. Then the most common one is in the block explorer. You will go to the block explorer and then you will check the contract. Let's say USDC Ether scan or USDT as well. And then when you click in contract, you will see that the ABI is here, contract ABI. Or if you are deploying a new contract, so you are writing a new contract, right? So let's say that you're using Remix. And then if you have this contract, let's say this one, I just created this simple contract. So you can come to Remix and then you will see this option Solidity Compiler. And then you can scroll down and then you can have the ABI of this contract that I just wrote, right? This is when you are writing a new contract, you can get the ABI from here. So if you deploy a contract, you can get the ABI of that contract from here in Solidity. Or there are also some other ways, but yeah, that would be too complex. That's the easiest one, Solidity, Remix. More questions? Okay. So to initialize the contract, remember ABI and address. And then I'm storing this in the variable called contract instance. And this contract instance is the variable that we are going to use to interact with that specific contract all the time. So what I'm going to do now is just to create 3 functions, one to get the name, one to get the symbol, and one to get the total supply. So name, symbol, and total supply. And then you can see that I will repeat the same pattern every time. So in name, I will basically just write contract instance dot methods dot name, because this is the function that I'm calling inside the smart contract dot call. Just like that, I am interacting with the contract and calling the function name, which will return the name of the contract. And then the same here, contract instance dot methods dot symbol dot call, and now I'm calling the function symbol in the smart contract that will return the symbol, you will see. And then here, contract instance dot methods dot total supply dot call, and we are interacting with the total supply. We are going to get the total supply of the contract. Any questions so far with this? Up. Which line? Yeah. Any other questions?
The uppercase variable.
Sorry?
The uppercase address variable.
Where do I get that one?
Why is it uppercase?
Why, sorry?
Why is it uppercase?
Oh, let's put it like that then. I don't know. I can just call it whatever I want. I just put it uppercase because it's a constant that will never change, because it's that address, but that doesn't really matter. Yeah, I guess when it's a constant, you put it uppercase, no? You know more JavaScript than me. Normally you put a uppercase when it's a constant, no? Yeah. Because this is the contract that we are interacting with, right? And this contract will never change because we are interacting with this contract in this app, right? Yeah. Any other questions? Perfect. So remember, we initialize the contract in this line 21, passing the ABI and the address. We store that in this contract instance, and then to interact with reading functions, that's the thing, with reading functions, It's just that easy. Contract instance dot methods dot name dot call, or dot symbol or dot total supply. Then we will store the result. Oh yeah. Oh, the .mjs and .js? Oh, .json. Oh, not really. I just put .mjs because I'm already used to the export way and all these things. But you can put the JSON as well and it will work. Or you can even do this. Wow, someone hit his head. You can even do this, for example. Just copy all the ABI, and instead of putting that, you can just put that here too. But that will be too much. So I just basically copy paste the ABI inside my contract initialization here, and then you are not importing any JSON or any .js. You are just putting it there. The most important is that that array has to be here anyway, right? That's the only thing that you need to put here in any format. So yeah, there is no difference of JSON and JS. Any other questions? Okay, so we are going to call the reading functions, and then we are going to store that in this result variable. So for now, let's just console log name result. Then the same here, just going to the same cons result, await, and then console.log. Symbol result, and then total supply result. Any question with these three functions? The what, sorry? Oh, because we are calling the contract. It's an asynchronous call. We are calling the contract. We are waiting that the contract return a result to store that here. Otherwise, I don't think it will work. Yeah, but we can even try. We can. Yeah, let's try to call the total supply without the await. Maybe it will. I don't think it will work, because then that's a call that you need to call the blockchain. The blockchain will return the result, and then you need to come back, and that's not really synchronous. But we can try too. So what I'm going to do now is just to connect the buttons to these functions. So to do that, I just need to type on click equal, and then here name, here symbol, and then here total supply. Okay, remember that the total supply is not await. So let's see if it works. Judith, tell me. I'm your friend now too.
I'm just seeing you write something coded solidity as well. So I'm just.
But this is JavaScript. I'm not doing any solidity.
Okay. But most of the code is React, so I'm hearing about solidity.
I will, yeah, that's the thing. I would like to even do some solidity things, but that would be too overwhelming. But that would be really useful. But yeah, for today we are not really doing solidity.
I'm just so curious. I'm new to Web3, and I'm just so curious.
If we have time, maybe we can do some solidity, because yeah, I noticed that I was teaching a little bit of solidity in universities in Nairobi, and it went really well. They really learned. But for today, is this thing of the bounties. But are you lost in any of the code of the React app?
So I do React.
Oh, okay, so you are good with this.
Yeah.
That's what you need to be good for today. Don't worry. Any other questions so far with this? Yeah.
So the moment of trying to implement plugin, and then I got this bubble.
Oh, like a Babel error there.
Yes, bubble or something.
That doesn't matter. I don't care about that Babel thing. But yeah, that was showing like an error there in yellow. I remember that, but that's fine. Just make sure that you install the plugin, because if you don't install the plugin, maybe that will be the error, that you are importing something that doesn't exist.
So I installed I actually read something that watching it down, but
It's showing you an error.
but the bubble something.
But even with that, is it still working or is not working at all? Like you're able to get this?
So at least I do the X. I click the error out. It goes on.
Oh, really? We'll need to check. Okay, after this, I'm going to check that there with you. I don't know what. I don't even know about Babel, but we'll figure it out. That's fine. So yeah, for now I have these three buttons that will interact with the contract. The get name will return the name. So if I click here, oh, okay, something important. This is really important. MetaMask is connected to Swisstronic, right? But if I am connected to another blockchain, that will not work because we are supposed to interact. Let's say I just changed to Ethereum mainnet, and we are supposed to interact with this contract in the Swisstronic network. So if I try to call this contract in the Ethereum network, that will not work. So as you can see, I'm connected to Ethereum here, and if I click in get name, we get the error. Yeah, that is just not working. That will just break. But then if I change to Swisstronic, and then if I click in get name, we get that the name of this token is a Storm. Oh yeah, the token is this one. It's called Storm. And then if I click in get symbol, the symbol is GMK. It was just a random guy that published a token that is called Storm. The symbol is GMK, and then the total supply. That's why we need the await. Otherwise, it will not work. Or it will return a promise, but yeah, that's why we need to put the await here. And then if I call the total supply, this is the total supply of the token. And now, let's say that I want to talk to this other ERC20 contract. So I just copy this address, and then I update the new address here. And now the name will not be a Storm. Now the name will be GH, and the symbol is not GMK. The symbol will be JL. So get name is returning GH, get symbol, and get total supply. And now we are interacting with contracts, with reading functions in Swisstronic with the contracts. Any questions with this so far?
Is there a way that can we directly connect to system if you are connected to another chain?
Yes. I created a Web3 plugin for that. There are different ways. So the easiest one, the manual and easiest one is just to come to chainlinks.org in case that you don't have the chain in your MetaMask. So you come here, you type Swisstronic, you put include testnets, and then you see Swisstronic testnet here, and then you can click on add net to MetaMask. And then if you don't have Swisstronic in your MetaMask, it will pop up MetaMask to connect to Swisstronic. In this case, I'm already connected, but let's say I change to Arbitrum. I didn't change base. Okay, so I'm in base right now, and then if I click to add to MetaMask, you can see that Swisstronic is popping up, and then it's asking me to change to Swisstronic network. And now I'm connected to Swisstronic. So this is the manual way for the user, but then there is another plugin that I created for that. So then you will need to install this plugin, npm install Web3 MetaMask plugin. You will need to do the same thing, register plugin, web3.register plugin, new MetaMask plugin, and then call this function, switch to Swisstronic. So web3.metamask switch to Swisstronic, and then it will pop up MetaMask in the front end, and it will switch to Swisstronic. If you need that. So remember that it's important that the user is connected to Swisstronic, otherwise you will get this weird thing of why this is not working, because you are trying to interact with a contract in a different network, and that will not work. So for example, one of the submissions that I got from these bounties that I was doing was this one from Ghana. And something that he implemented that it was nice is like, please switch to the Ethereum mainnet to use this application. And he's just prompting this alert since the beginning, because if I try to interact with the dApp, being in a different network, that will not work. And then that's just like a little nice user experience that is asking you, okay, so now I can change to Ethereum mainnet. And then if I refresh, you can see that now it's not showing me the alert because it's detecting that I'm connected to Ethereum mainnet in this case. In this case, because this app is in the Ethereum mainnet, not in Swisstronic. So yeah, this is how we interact with the Swisstronic contracts with reading functions. Any questions with this before we jump into writing functions, which is more complex? Everything will be recorded, but that's why I'm telling you, you can make a dApp only interacting with reading functions, and that still will work. You can create a dApp that, for example, will allow you to put a contract address and then read the different functions of that contract, like get the name, get the symbol, get the total supply. And then when you input a new contract address, it will return the name, the symbol, the total supply of the new address without initializing an account to do writing functions. So that's why I'm thinking reading functions are way easier to interact with contracts because you can see that I'm not initializing any account here. I mean, here I initialize the account. But even if I disconnect my account, it's already disconnected. Yeah, you can see that there is no accounts connected. Disconnect. I don't have any accounts connected. Connect accounts. I don't have any accounts that are connected. You can see no accounts connected. And I can still, let me see if I'm connected to Swisstronic. I can still get the name. Oh, it's not getting the name. Oh yeah, I can still get the name, get the symbol, and get the total supply. I can also do this in scripts, and it's just a little bit easier and less code, but it's just better to do it in a React app, so you can actually reuse this code too. Yeah, I don't know if you have more questions. Now I can interact with writing functions. No questions so far with reading contracts? Okay, so let's touch a little bit of Solidity. I will try to be a little bit fast. And then let's create a contract. To use Solidity, you can go to remix.ethereum.org. And then you can create a new contract just by create a new file. And then I will call it kampala.solidity, no Motoko. And then the structure of the contract will always have the license, the Solidity compiler, and then the contract object. So SPDX license identifier, and then any license I just put MIT. That's always just a line that you need to copy paste. Then pragma Solidity. Here we need to specify the Solidity compiler version. And then we create a contract object. So let's call it Kampala. So this is how you create a smart contract in Solidity. Solidity version here, Solidity compiler version, the license, and then the contract object. And then this contract, to make it really easy for today, will have the state variables, a reading function, and a writing function. So let's do maybe a smart contract that will store a message, a string, right? So let's put a string message. Simple. And then a writing function that will update message. Then this will accept a string as a parameter that will call new message. External. This keyword external is just to allow the contract to be able to show this function externally, that it can be called from anywhere outside, like in the blockchain, not only within the smart contract. And then what we are going to do in this update message is just basically putting this message, updating this message with this new message that we get from here. Any question with this Solidity contract? It only has a string state variable that is called message. And then in this update message, what we are doing is just updating the message with the new message that we are sending here as a parameter. Yeah?
So what's the rule of string?
Oh yeah, I think that's too complex to explain. just because Solidity has different ways of using the strings and the uint. If you, for example, send a uint, you will not need to specify that that's in the memory, because that memory will kind of disappear after the execution of this function. That's why always when you put a string, you need to put memory. Just keep that in mind. When you interact with the strings in Solidity, you always need to put memory. Yeah, but that's just a keyword that is annoying, but you need to have it there. Any other questions? And then the reading function, Judith, what do you think that the reading function should do here in this contract? Yeah, we have a writing function that is updating the message, right? Updating this message of line 7. That's this writing function that is called update message, right? Do you understand this update message? Okay. And then we need to implement a reading function that does what? You don't have idea? Okay, someone has any idea of what the reading function should do?
It should read the updated message.
The message, right? Perfect. So let's call it function, let's say read message. And then this function is called external view returns because it's returning this message. So this reading function will return the message that is here. Otherwise, we will not be able to access to the message. Returns, and then in returns, we need to specify what are we returning, and we are returning a string, and then return message. And basically, this is a smart contract. Let me just close this. Now we wrote a smart contract, and we are going to interact with this smart contract. This smart contract has only one variable, message, one function to update the message, and one function to return the message. Any questions so far with this smart contract? And if you want to test it, you can come here in deploy and run transactions. I don't know why it's showing an error. Let's see what is the error. SPDX license identifier. Maybe I make a mistake. I don't know what is the error. Yeah, that should work. Just leave it like that. Yeah, that's fine. So if I come to deploy and run transactions, Remix gives us like a virtual machine that is called Remix virtual machine, just like a testnet environment to deploy the contract and play around with the contract. So if I select my contract that is called Kampala and I click in deploy, now the contract is deployed in this virtual machine, and we can see that we have two functions. The read message, if I click in read message, this will return the message, which is an empty string, so there is nothing. And then I can update the message saying, hi, Judith. And then if I click in update message, we just updated the message, so I can just click in read, and now we have this message there. Any question with this interaction in Remix? That's why Remix is really useful to write smart contracts and then test it here. So I just wrote this smart contract, reading functions here, and writing functions here. Yeah? Oh, the read one. Which, where here?
Yeah, in the reading function, string returns string.
Oh yeah, we just need to specify what is the value that is returning, and this is returning a string. The memory, remember that always when you put a string, you need to put memory. Because if I remove memory, this is showing me an error. That data location must be memory or call data, but we don't need to dive into these things. So that's why when we interact with the strings, we always need to put just memory. That's fine. Or I can just do something really quick to create a new one that is called counter. And this smart contract counter will just have a variable that is called, let's say, count. And then we'll return current count. Let me just put this here. So this smart contract counter will only do two things. Writing function will increase the count, and then to increase that count, what we are doing is just count plus plus. So we are increasing the count by 1. The count is this state variable that we have. And then the reading function return count, external view returns. And then here you can see that we are returning a uint256 and we don't need to put memory. Here we only have returns, uint256, and then return count. Any questions with this smart contract too? It's the same. We only have one state variable, which is a uint256. It will be a number that by default this will be 0. And then when we call the increase count, then that will increase the count to 1. And then when we call it again, it will increase the count to 2 or 3 and so on. And then this will just return the current count. That will be 1 or 2 or 3, etc. Here you can see that we don't have the string memory. We only have uint256. External view return uint256. Any questions with this one? Let's call it Kampala 2. And then if I deploy this one, like to test the contract here, Kampala 2, deploy, and then return count right now is 0. Increase count now is 1. It's too small, but fine. I click here again. Now we have 2, and so on. And I'm just increasing the count. So that's the same of the message, but just with a uint256. Yeah. Oh, okay. That's what I'm going to do now. Good question. But yeah. Any other questions with the contract itself? No? Don't be shy. I am friendly. I try to explain in an easy way. No? Okay. So what we are going to do now is instead of deploying in this Remix virtual machine, we are going to deploy to Swisstronic, right? And maybe, I don't know if I should create a new app. Yeah, maybe I will create a new app. Yeah, to make it easier for you to understand too. So I will come back here, npx create React app, my contract. And then in this my contract, we are going to interact with my contract that I'm going to deploy to Swisstronic. So let's deploy the contract that has the counter. So this counter, we only have these two functions. So what we need to do is in the environment, instead of putting Remix virtual machine, we are going to choose injected provider. So injected provider will connect to MetaMask. So now it's just connected to MetaMask. My account, because I already connected an account, but let me just disconnect the accounts. Okay, so right now you will see this because you don't have any accounts connected. So when you click in injected provider, it will ask you to connect an account. In this case, I will connect this Vault account because I have 48 Swisstronic tokens here. To deploy contracts, we need to have tokens because we are deploying a contract in the blockchain. And now, as you can see, I just connected my account. Vault. Yeah, but it's not fetching the balance here yet. I don't know why. Let's do this again. Yeah, so as you can see, I have 48 tokens of Swisstronic. And then if I click in deploy, this will not deploy here in Remix. This will deploy to Swisstronic. So I just click in deploy, and then you can see here, contract deployment. This is the cost of the transaction, confirm. Okay, and now the contract has been deployed, and then here is the contract address. You can see it here, or you can also see it here as well, contract address, and then this is the address. So now I will create a new React app to interact with this contract in Swisstronic. And remember that this contract only does these two things, increase count, return count. The only thing that you need to know as a JavaScript developer is the name of these functions, and that's it. So what I'm going to do is to copy this contract address, open the new React app, my contract. Let me just close this one. Yeah, just close this. Okay. So code. Oh, yeah. And then I'm just repeating the steps. Okay, we are a little bit late, so I will go a little bit fast, but I'm going to do the same steps as the first app. So first thing that we need to do is to install the web3 library. npm install web3. Then after that we need to install the Swisstronic plugin. So Swisstronic plugin is here. This one. And then we can see in our package.json web3 is already here, and Swisstronic will show up here. Okay, so just install the Swisstronic and web3, then import web3, import Swisstronic plugin, import ABI of the contract, of counter contract. So to import the web3 module, import web3 uppercase from web3. To import the Swisstronic, import Swisstronic. I'm going to publish this on GitHub as well, so you will be able to use these too. Import the ABI, so we need to create again ABI.mjs. And then here is where you can see the ABI in Remix. So the ABI of my Kampala 2 contract is here. So I just copy this, cons ABI, and then you can see that the ABI is way shorter. It only has the functions increase count and return count. And then export default ABI, and then import ABI from, let's see, yeah. Okay, so far I just did these 3 things: import web3, import Swisstronic, import the ABI of the contract. Then we need to initialize the web3 object, then register Swisstronic plugin, initialize contract, and then we can call the contract. Okay. So the first one is to initialize the web3 object, const web3 equal to new web3. And then here, remember that we need to put window.ethereum. Window.ethereum. To register the Swisstronic plugin, web3.register plugin, new Swisstronic plugin. Remember that this is in the documentation of the Swisstronic plugin. Here, yeah, oops, Swisstronic, yeah, is here, new web3, and then I will need to take this RPC endpoint and then put it here. Then to initialize the contract, const contract equal to new web3.it.contract, and then we need to pass the ABI, and then the contract address. In this case, the contract address of my contract is here. This is the contract that I just deployed. So I just put the contract here. And then to call the contract, we will need to put contract.methods. What was the name of the function? Return count. Return count dot call. And just like this will return the count. Const result. This will return the current count of that smart contract. Return count. And then let's just print that in the console. Current count. And then I will just create a button again, just to return the current count. Return count. Okay, so this should work. And then it should return 0 right now, because right now the count is 0. So let me just run the app. npm run start. in this app, we are going to interact with the return count and also with the increase count. Okay, so if I open the console and then I click in count, you can see that the current count is 0. So now let's implement another function to interact with increase count. Increase count. Okay, so now to interact with increase count, because we are sending a transaction, we are interacting with a writing function, we will need to have an account. So we need to ask the user to connect an account, and the user needs to have funds to be able to interact with that function. So async function increase count. So the first thing that I'm going to do here is connect user's account and then call the writing function increase count. So to connect the user accounts, that's why we need to use the web3.eth.request accounts, and then the user will connect the account. So accounts, remember that this will return an array of accounts. And then to interact with writing functions, what we need to do is to call contract. Remember the contract instance .methods. In this case, we are not calling the return count, we are calling the increase count. I think it was called like that here. Yeah, increase count. And then instead of .call, because we are not making a call, we need to put .send, because we are sending a transaction. And then in this .send, we need to open parentheses, to open the curly braces, and then we need to specify the account that is sending the transaction. In this case, this account in the slot 0, which is the first account that the user connected. Any question with these lines so far? Maybe I'm going a little bit fast because I was getting a little bit late. But I'm happy to go back through the code. The only difference of reading functions is the .call, and then the writing functions is .send, and then we need to specify which account is sending the transaction. That's the only difference. That's why we need to connect the account here first. But then you will not be able to create a dApp. And the idea is to create a dApp with the Swisstronic plugin. But then if you are using Hardhat, I don't know. I think you can still install the Swisstronic plugin. But then you will not be eligible for the bounty. And that's the idea of today. Oh, for the ABI. To deploy the contract. To deploy contract, you need a bytecode. But then what Hardhat is doing is that Hardhat is compiling the contract. So Hardhat is getting the ABI and Hardhat is getting the bytecode. So you don't need any of those because Hardhat is already doing that. But this is more a manual way of how you can do it without having Hardhat, for example. But Hardhat will already give you the bytecode and the ABI. You have a question? Use what? web3.js? Yes, but I think that's too complex. Not too complex, but that's just a lot of lines of code that I feel that was not really useful because not everyone deploys contract, but everyone creates apps to interact with contracts. So that's why I don't teach that. But to deploy contracts, basically you will just need to use to create a contract instance only with the ABI because you don't have an address, right? Let me just do it like something really quick here. Let's say deploy. What you need to do is something like this: const contract, and then new web3.eth.contract, and then the ABI. Not the address because you don't have an address, right? And then you get this contract instance, and then you type contract.deploy, and then this will receive two parameters: the data and the input, I think. The data will be the bytecode. That's why we need the bytecode from Remix when we need to deploy the contract. And then the input will be the constructor arguments in case that your contract has any arguments in the constructor. And then you say here like arg1, arg2, etc. And then what you need to do is store this in, let's say here, a deployer, and then deployer.send from accounts, something like that, just really quick, because that's not really, I think Remix or Hardhat is just easier instead of the manually deploying a contract with web3.js, but this is how you can do it. And that I can help you with that maybe later after the workshop, but yeah, you can still do that. Yeah.
If you provide a link, you don't want it to not show.
And then what?
And then you want it to not show. Like if I take the
MetaMask must go
and
Or the wallet that you have will pop. I mean, when you say injected provider, you mean here in the line 14? Oh, in Remix. Oh, here MetaMask is not showing up. And what do you have here in accounts? Empty. Okay, let's check. I will help you with that. I will help you to check what's going on there. But MetaMask should pop out, or at least the wallet that you have. Are you sure that you have MetaMask? Yeah, or the wallet that you have should. But I will go there and then I will help you. But yeah, then this is. Oh, any other questions so far? We just have the React app with these two buttons. This returns the count, and this returns the increased count. So if I click in increase count, what we are doing is first requesting the user to connect the account, and then second, we are going to send the transaction. So this also needs to be await, and then I want to store this in this variable receipt, because this will return, once the transaction is executed, this will return the transaction receipt, and then I can just print here, transaction receipt. Just for us to know, like, okay, now the transaction was executed. So I click in count, we have 0. And then if I click in increase count, MetaMask is popping up to first ask me to connect an account, so I will connect this account. And then it will pop up again to interact with the contract. Now it's saying contract interaction. This is the fees that we are paying. Confirm. Once the transaction is executed, it will return the transaction receipt. Okay, that was really quick. And then I can click in count again, and now we can see that the count is 1. Then if I click in increase count again, MetaMask will pop up again. We'll interact with the contract to increase the count. Still 1, still 1. Now it's count, and now it's 2. And that's how we create the dApp to interact with reading functions and writing functions. So remember that this is writing. Let me just put this here. Increase count is writing, and this is just reading function. Oh, I think that will not work. Oh yeah. Yeah, so I will also put this in GitHub. Any question before we go for lunch? And then we will stay here. I will stay here the rest of the day and then just go in one by one. If you have any questions, and that would be easier than me just explaining things here. But yeah, any other questions? Sorry? GitHub. Oh yeah, mine. Yeah. Santiago DevRel. Yeah. Santiago DevRel. I will publish that. When we go for lunch, I will publish that. I will actually put this on Twitter with the yeah. I will take a selfie. I will publish the selfie with the GitHub too. And then yeah. Okay, I will publish that selfie with the GitHub repo on Twitter. Twitter is also Santiago DevRel. Let me just stop the recording. So you can just come to Flick. Just record this. You come to Flick, you create an account, and then you just need to connect Flick with your GitHub. Oof, I don't know. Okay, let's see. It's taking some time. This is also important, so when you are having apps, and if you want something for your portfolio, so you just deploy the app on Flick, and then in an interview you can share the link, or you can share your screen or whatever. instead of showing code. A recruiter will never want to see a code. They want to see a dApp that is working. Okay, so once you log in, you come to the deploy site, you add a new site. You can see all the React apps that I have here. Deploy my site. You will connect your GitHub account. In this case, I will need to give permissions to interact with that specific GitHub repo. Remember, if the dApp is not deployed on Flick, you are not eligible for the bounty. So I will come here, I will look for the repo that I wanted to deploy. This one, Kampala counter contract, save. So I just give Flick the permission to interact with this repo. Then I look for Kampala counter contract. I click on deploy. In this case, it was a React app, so it will show this here. There's also other frameworks. Create React app, deploy site. Oh, okay, I forgot something. That's really important. When you do this, you need to come to your package.json, and then you need to specify the home page. So home page, in this case, is a dot because this is only a React app of one page, and that's the home page. So you just need to add that, then update the GitHub repo. Then push this. Okay. And then I will just redeploy. And that's basically everything. You just connect your GitHub, you select the repo where you have that, you update the package.json with the homepage, you deploy here, and then that should work in a few minutes. In 5 minutes, I'm going to show you the link, hopefully. And that's what you need to do too, to deploy this on the link. And then I will create a Google form where you can send the GitHub repo link, the Flick link, and that's it. And then something else if you want to add a comment or something. And then I will share the link to the Google form where you can submit this on Twitter. So let me just create a Google form. And then just check on Twitter, the tweet that I will publish in a few minutes. But yeah, that's basically everything. I will show you in a few minutes once this is deployed. And that's what I wanted to show you with Flick, that you need to deploy the dApp on Flick. Any questions? Okay. Perfect. Now you can go back. Thank you.